Hello, welcome to everybody to this session of CodeRage, Flux Application Architecture in Delphi. I am Daniele Spinetti and I'm a senior software engineer. I'm also a book author. I wrote the Delphi cookbook, the third edition, in co-authoring with Daniele Spinetti. And I'm a very active member in the Pursues community. In this slide you can see my contacts, so if you want to contact me in private for some questions or others, you are welcome. So let's start with the agenda. Start with why. So I'm going to start with the why of this architecture. Then there is an introducing to Flux architecture. So what is Flux and the Flux core concepts? So which are the main concepts of this architecture? Then I'll show you how you can implement this architecture in Delphi, and some special consideration for example for network requests and asynchronous calls. And then I make some conclusions about this architecture and how I develop in Delphi. So start with why. The first thing is find a good application. Architecture is not easy, but your application an architecture is essential, but you have to define an architecture for your application. It's important and that's essential, because an application have an architecture. This is very fundamental thing. So like it or not, our application is going to have an architecture. There is no, in this case, there is no the best architecture, but there is the best architecture for your current application. What does it mean? For example, there is no the silver bullet, so an architecture that is good for all your application, that resolve all your problems, etc. But there is the best architecture. What mean best? Finish the project on time, with quality, less bugs as possible. no bugs is preferred, and easy collaboration with your teammates. Because you, for example, you have different teammates, and the level and the structure of this application architecture have to considerate the team that will use this architecture. So also these things are very important. Flux is very simple to understand, and there is no code for it, because it's just a way to better structure your app. For these reasons, I believe that Flux is very good for all of that. So it's very good, because it's a very simple architecture to implement. Flux architecture is what is Flux? Flux is the application architecture that Facebook uses to structure client-side web application. It's a clean architecture. So Facebook used this architecture for web applications, but it's a clean architecture, so its feature and simplicity allow to adapt it very well to other kind of projects. For example, Delphi, it's very useful in client-side application, multi-platform, mobile applications, etc. It's very important in this way. This application architecture divide the structure in three main parts: the view, dispatcher, and store. That we are going to I'm going to show all of these parts in details. These three parts communicate through events or actions. This is for now the big picture of what is Flux. So structure and data flow of Flux. So Flux is based on an unidirectional data flow. It's central to the Flux pattern. So like the image show, in this case, Flux is an unidirectional data flow. So action, dispatcher, store, and view. And the below diagram should be the primary mental model for the Flux programmer. So every programmer that approach to Flux, this is your mental model, this image. The dispatcher, store, and view are independent nodes with distinct inputs and outputs. And the action are simple objects that contain the new data and identifying type property. So the term which is the action. So now we are going to examine in detail every structure in Flux. So action, dispatcher, store, and view. But this is the data flow: the action, dispatcher, store, and view. First one, dispatcher. The dispatcher is the central hub that manages all data flow in a Flux application, and it's essentially is a registry of callbacks into the store and has no real intelligence. It's a simple mechanism for distributing the action to the stores. When an action occurs, the dispatcher has the responsibility to dispatch this action to the store. Each store registers itself and provides a callback. So the store are registered to the dispatcher, and when a dispatcher dispatch an action, a callback that each store have registered in the dispatcher were called. The dispatcher processes action, for example, also in a user interaction. The dispatcher processes the actions and invokes callbacks that the stores have registered with it. So it's it's also used for user interactions. Every store will receive every action. This is a must for Flux application. So every store will receive every action. Every action, what does it mean? In the case of view, for example, there is a user interaction. So the user click on a button, click on a view, and this is the user interaction. These user interactions become an action in this architecture. The action is dispatched by the dispatcher, and the store receive this information. So this action has occurred, and the store can apply at this time some business logic. The dispatcher is this one. User types in a title for a to-do and hits enter. The view captures this event and dispatches an had to-do action containing the title of the to-do. Every store will then receive this action. So every store, this is a must. I said previously, every store will receive this action. So every store will receive every action. Receive the action and apply its business logic. So the store know that the action of type had to do has occurred, and then it can apply appropriate logic based on this action. Then we have the store. The store contains the application state and logic, and manage the application state for a particular domain within the application. So the data in a store must only be mutated by responding to an action. This is the only way to mutate a data inside the store, by an action. What this mean? This means that there should not be any public setters on a store, and a store can have only getters methods. So you can only retrieve information from the store, because if you have to set something in the store, you have to do it by an action. Store decide what action they want to respond to. So when an action occurs, the store decide what to respond to this action. They aren't the same as models in MVC architecture, since models usually try to model single objects, or for example a single record or a tab or of a table, while stores in Flux can store anything. As I said previously, manage the application state for a particular domain. So the difference between a model in an MVC or similar structure and Flux stores is this one, that the store manage a particular domain of an application, while the model in MVC pattern usually try to model single objects. They respond to action according to current state. So it means that apply the business logic to respond to an action, execute business logics, and emit a change when they are done. So when a store change because had applied some business logic, emit a change to say to the interested parts of the application structure that the store are changed. Who are interested of this change are the view are interested of store change, because they have to for example redraw something because the store has changed. So every time a store's data changes, it must emit a change. Here's an example. Store receives an add to action. So we continue with the previous example. It decides it is relevant and adds the to-do to the list of things that need to be done today. And the store updates its data and then emits a change event. So emit a change to say, okay, now I'm changed. Actions. Action define the internal API of your application. They capture the ways in which anything may interact with your application. And they are simple objects that have a type field and some data. So a type field to identify uniquely the action, and a payload, so some information, some data that the action bring with it. And action should be semantic and descriptive of the action taking place. They should not describe implementation details of the action. An example is use delete user rather than delete user ID, or other example are clear user data, refresh credential, etc. So they should not be described implementation detail, but more generic and not describe the implementation. The actions creation may be wrapped into a semantic helper method which sends the action to the dispatcher. But we will see in the detail the thing in the detail in the next slide. An example of the action. So remember that all store will receive the action and can know they need to clear the data or refresh credential by handling the same delete user action. And this is the example. So when a user clicks delete, for example, on a completed to-do, a single delete to-do action is dispatched. And on the slide you can see JavaScript object notation, also known as JSON, that identify the action. In this example we have the type of the action, delete to-do, and the to-do ID. This property identify uniquely this to-do. So this number identify it uniquely. Views are the the last core concept in a Flux architecture are controller view. Are also very common in most GUI MVC patterns, MVC, model view, view model pattern, etc. Data from stores is displayed in view, so the view responsibility is to display the information on the store, display this information to users. They listen for changes from the store and re-render themselves appropriately. So when a change occurs in the store, the view are notified and re-render themselves appropriately. And views add new actions to the dispatcher on user interaction. So are also responsible for taking user interaction. For example, a click on a button and dispatch this action by the dispatcher. Example, the main view subscribed to the to-do store, so because view are subscribed to a particular store change, it touches a list of the to-dos, renders them in a readable format for the user and in the way the user can interact. When a user types in the title of new to-do and hits enter, the view tells the dispatcher to dispatch an action. So, for example, the user create this to-do, click on the save button, then the view is responsible to dispatch this action. The dispatcher dispatch this action and all store receive this action. And the to-do store handles the action and adds another to-do to its internal data extractor, or in this particular example, but and to do a store when an action arrives, implement some business logic. In this example, add another to-do to its internal data structure, to its internal list of to-do, and then emits a change event. So to declare to the extractor, okay, I'm changing. Or I am changing because I add another to-do to my internal structure. The main view is listening for the change event. It gets the events, so this same view is listening for the change event. So when a store, in this particular case, the to-do store has changed, it gets the events, gets new data from the store, and re-renders the list of to-do in a user interface. So in this example are very complete example for all of the Flux architecture. So Flux data flow, we can piece the parts of Flux above into a diagram describing how data flow through the system. So the flow is very simple. We would describe it by the last example in the views example. So which is the data flow? The view send action to the dispatcher by, for example, a user interaction, like a click on a button. So the user complete a form on your mobile application or whatever you want, and then click on the save button. The view intercept these events and send action to the dispatcher. So okay, this action occurs by the view. The dispatcher send action to every store, because this is the must of this pattern, that all store receive all actions, and then store apply the business logic that have to apply based on the store consideration, and then store emit changes and view. So store emit change and view re-render. The view get the new data and re-render themselves appropriately. So to let to show, for example, new data coming from this new action. Okay, Flux Delphi architecture. So now I'm going to show to you how we can achieve this architecture in Delphi. First step is how implement the views part in Delphi. So first step is to map Flux element with Delphi. The first element is very easy because I suppose in your mind this map it's very intuitive. So a view can be a form in Delphi application, and this is how I implement the architecture in this case. So the views in Flux architecture are represented by a form in its Delphi implementations. The dispatcher, we need an event bus, a dispatcher. So I used my open source project, Delphi Event Bus, that for who don't know, this framework is super easy to learn and use, and is designed to decouple different parts and layers of your application. It's event driven and attributes based API, so you can declare by RTTI attributes the event to register, for register to the event. The very interesting thing, because for example, if you know, it's very similar to messaging of messaging framework inside Delphi, but it supports different delivery modes, so you can choose where to receive this action. So for example, in the main thread, in a background thread, etc. So this is a very cool feature of this framework, the support of different delivery. And if you want to know more more of this framework, this is the link on my GitHub project, and you can look it. And in Flux Delphi architecture, the dispatcher is my Delphi event bus, so a framework that lets you to register for event and send events. Then in the case of Flux Delphi architecture are the actions. So actions are not complex. They will be implemented as simple Delphi objects with two main attributes. The type. What is the type? The type is a string that identifies the type of the event, and data, that is the payload for this action. This on the slide you can see an example. Flux application .create. So the first parameter is for example a constant string that represents the action get wines. For example, you want a list of wines because it's related to the final demo. So for example, this is the action, and the payload is the list itself. So it's the list of the resource, or the request resource in this case. Stores. Stores contain the status of the application and this business logic. This is perhaps the most difficult to get Flux concept. This is the most difficult concept to understand. They are similar to rich data models, but they can manage the status of various objects, not just one. So are about a domain, a particular domain. Stores react to actions emitted by the dispatcher, execute business logic, and emit a change event as a result. This is another thing that the stores do. Stores only output is this single event change. So, like I previously said, we don't have setter methods in the stores, but on the only way to set information in the store is by an action, and to know when a store change is to register to a particular action that is, okay, this store has changed. So on any component interested in a store internal status must listen to this event, so the store change event. So finally, stores must expose an interface to obtain application status. And this way, the view elements can query the store and update application UI in response of this change. So only the stores are a complex Delphi object. Okay, for example, this could be a question that you have in your mind. You understand Flux core concept and the data flow, but how Flux application obtain data, for example, by an external API, because by this diagram is not very clear, these things. I suppose when I have approach to this architecture, I have the same question. So where I obtain data, for example, by external API in this diagram. Okay, in this diagram is not clear. So we have to to update the diagram and insert a new component that is action creators. A network adapter makes the asynchronous calls to the corresponding API and returns the result to the actions creator. Finally, the action creator dispatches a corresponding type action with return data. So in this case, for example, there is a user interactions. For example, a request of a list of particular resource. The action call a particular method of the action creators to do these things. The action creator use a network adapter or a proxy or whatever you want. In this diagram is called by web API utils to make a web request to the web API. Then when the information are returned, the action creators create an action to dispatch with the dispatcher, and the store receive this action. Okay, this action arrived to the store apply business logic, and then emits, okay, I'm change, and then this change event return to the view, and the view re-render itself appropriately with the new change. So this is the new data flow with network request and asynchronous calls. But you can use this new element, the action creators, because you have many advantages. For example, your store are completely synchronous. This makes the logic inside the store very easy to follow, because bugs will be much easier to trace. And since all state changes will be synchronous, testing the store becomes an easy job, because you can launch an action and then assert a specific final state. So also testing is very easy in this way. All actions are triggered from an action creator. Having a single point, you create and launch all user action greatly simplify finding error in this way, because you have only a single point. Forget about digging to classes to find out where an action is originated, because everything starts in action creators, and because asynchronous call occur before everything that comes out of action creator is synchronous. So all of this thing is synchronous before arriving in the action creator, and this is a huge win that significantly improves traceability and testability of the code. So this is a very interesting way, action creators. So now I'll show you the application one installer app, how I implemented it, and some conditions. Here there is my Delphi 10.3 just started with my wine solar project group. This project group contains wine solar server that expose some REST API to manage this wine solar. So one to retrieve the wine list, one for save a new wine, and one for update an existing one. This demo is from Delphi DMVC framework by Daniele Spinetti. And this project group contains also two client applications, one developed by model view model design pattern, and one by the Flux. So this is the demo of this section, but as soon as possible I'm going to put all of these projects on my GitHub account, so you can also make some consideration, some comparisons from model view model and the Flux client, so about Jesus client and the way they are developed and implemented. So the server is running. Okay, so let's start with the wine solar client Flux. The first thing I want to show to you is the folder structures. I follow the Flux core concept. So in the actions there are all unit about the actions, dispatcher where there is the dispatcher, services where there are the outside services, so for example to call an external REST API. This is for implementing an service-oriented architecture. So all other services that there are no Flux service are in this folder, and you have to create a new unit and pass the unit here. And the stores folder where there are the stores. In this case there are only one store for the wines, and the views folder where there are all view. In this case only one view, that is the main form. Okay, let's start with the main form. We start from here. We have a full Flux data, so a full loop, so a full request. So we can I can show you a full path of the data and all the actors and the objects that are involved into these applications. So the first method I want to show you is initialize dependencies. When I initialize all the Flux core concepts, so I get the dispatcher, the wine action creators, the wine store, and I register the view at the wine store on the dispatcher, because if you remember, the view are subscriber from the dispatcher, because where a store change, the view are advised. So the view are advised, so you have the meter, because the view subscribe from this event. Also the dispatcher are registered the wine store, because the wine store are advised when a Flux action are fired. So this is the case. First thing, all I show you the dispatcher, but all units are in this way. So I have the type and interface that represents the Flux core concept. For in this case is the Flux dispatcher for register, unregister, and dispatch an action. And then I have a function to get an interface of this type, and then in the implementation section there are all the implementation code, the real implementation code, so the class, the dispatcher, the dispatch method, etc. In this case, it's the dispatcher. It's a simple adapter, because all of the things are made by my T event bus framework. So it's a simple very simple adapter. When I have to dispatch, I call the post method about Delphi event bus. When I have to register in the dispatcher, I call the register subscriber and register, etc. This is the dispatcher uses. So a simple, very simple adapter pattern. So if in the future I want to change, also I change the event bus with something else, I can do these things. Then, so the same thing where for wine action creators. This is the action how you can do. So save wine and request wine. Thus the action creator interface. The store, also in this case. So if you remember, the store have no setter function. You can only get information from the store. In this case, I have only one method: get current wines. And then register. How the register method work? So here, by using Delphi event bus, you have Delphi RTGI attribute subscribe. So how this code works: if an event of type twine store changes has fired, this method has invoked where in the, because the delivery mode is the thread mode dot main in the main thread. So this is a very cool feature about Delphi event bus. You can do this thing. So when an event of the type twine store change has fired, this method was invoked. So let's go by step. I show you a first demo about this application, and then I go again into the code. Okay, this is the application. If I click on the wine list button, I retrieve all the wine. I also the two CodeRage wine. If I click on one wine, I can modify it, so I can change the country from Spain to, for example, England. Okay. Or I can create a new wine. So name new CodeRage wine, region, I don't know, Tuscany, for example. Here, grapes, rage. I invented this grapes, country Italy, save wine, and new CodeRage wine was saved. So this is the application, a very simple application, but I can view all of the Flux concept in this application. So go again to the code and try to make a full path. So what happened when I click on the wine list? I invoke the wine action creator because all start by action creator. I ask to action creator, okay, I have to request a wine because here there is a user interaction. So request wine. What happens when request wines? Go action creators, request wines. There is a simple method doing background that run this procedure in the background, because this is a background request. So for example, in this specific case, I have to retrieve some data from an external server, so I cannot do it in the main thread. I have to do it in a background thread. And then I use the getWine REST API service that I show you. It's here, get wine list, and retrieve the wine lists that are on the server. This is also a very interesting feature about Delphi MVC that I personally developed. Is the REST adapter. So you have only to create to write an interface and specify the REST resource in terms of REST verbs and paths, what the function returns. If the function have to specify a body, you can use the RTTI attribute to specify the body as a parameter, or some params like this one, ID. You can specify the ID here. Then you have only to call the REST adapter, create REST adapt build, the host and the port, and the job is done. So in these few lines you have all the implementation to call an external REST API. It's a very interesting feature about Delphi MVC. So if you want, try this particular REST adapter, because it's very interesting. With a few of line you can reach a lot. You can, yes, a lot of time. You can of time, yes. So and then you retrieve the one REST API service like this interface, and you can call the API directly. So also, if you can see, get one REST API service dot get wine list. Okay. Then I use the dispatcher to dispatch a new Flux action. So the action get wines has occurred, and this is the data, so the list of wines. And what happens that the store responds to the action. So if the action is action get wines, then I update my current wines with this new data and emit a store change with the dispatcher. So the dispatcher dispatch twine store change create, and then I return on the view, and the view receive the on-wine store change and regenerate the wines adapter, because the list view in this case is binding with the wines adapter, one adapter, so it's made by live bindings. And then I can show the new list with the new wine. Another interesting things, it's about create a new wine. So when you have part of data, or you have specify an existing one, you call save wine, and here again the Flux data path. So wine action creator dot save wine. Here have to save wine. So if a wine contain an ID, I call update wine by ID. Otherwise I call save wine, retrieve the new wine list, and dispatch this action. So wines, I go to the store wines, have again this action, emit store change, the dispatcher emit the store change, and again the view are notified by the changing of the store and set the new list. So this is the Flux in the application. This is a very interesting, because all of these layer stores that represent the model, the view that represent the main form that represent the view, and the action dispatcher, all of these layers are separated, and we can test this layer independently. So we can go to running unit test, etc. We can change a view with another one, and the store, we cannot modify the store or modify the action creator, etc. So all the layers are very well separated and reaching an high cohesion and loose coupling goals. That is what a good architecture have to do. So this is the application written on the slides with the conclusions. So good, this is a very good clean architecture because it's just a way to backstart your app and there is no code for it. So I can see I only structured well my app. I don't see a specific code to make this architecture possible. So this is a very good and clean architecture. For this project, I create on my GitHub account the Delphi Flux seed. That's it, a seed project. So a base project, a start project with all the Flux core concept and other utils class to implement the Delphi Flux. So you can go in my GitHub and start by this project if you want to for your client application to implement this pattern. So how you can see, it's very useful pattern. You can test all the concept in isolation. This is the really good things. You can change the actors of the core concept, and the other one not have to change. So it's very well structured, and it's easy to build, because by dispatcher you have only to dispatch an event and register from the subscribe, and you have the event. You can choose by Delphi Event Bus also the delivery mode. So if you want in the main thread, you have to specify main thread mode. If you want the background thread, you have to specify background. So there are a lot of features, and this is very high for client side. It's a very good and clean architecture. Use it for your project, and you are happy. This is my thank you to enjoy this my session of CodeRage, and bye.